Okay, before we actually dive into this problem, let's make sure that we deconstruct it properly. What we have is a cylinder, and we are removing some of the cylinder. And what we are removing is basically 4 triangular prisms. So we are taking these things out. When we take that triangular prism out, we're taking out a triangular prism that is 3 inches in height. And I'm going to call it its height because in the formulas we use, that dimension is labeled as height. And in the formulas we use, we know that the volume of this whole thing is equal to this area times the height. So we're taking out 4 of those. And in the middle, we are taking out a rectangular prism, square prism, that is 2 by 2 by 3. So just to summarize what we're doing, we're going to find the volume of this cylinder, and we're going to take out this triangular prism 4 times and this square prism once. The remaining volume will be the volume of the paperweight. The problem reads that we have a crystal paperweight shaped like a cylinder with a star-shaped hole in it. The top of the star-shaped hole is shaped like a square with 4 points that are identical equilateral triangles. The height of the cylinder is 3 centimeters. Find the volume of the paperweight. Just to remind you, an equilateral triangle is a triangle with all 3 sides the same length. And we can see here that the base is 2 inches. So each of the other sides is also going to be 2 inches. So let's start working our calculations. Let's write down the formulas that we need in order to calculate the volume of the cylinder and then the volumes that we are removing from the cylinder. The volume of the cylinder is going to be the area of the base, it's a circle, pi r squared times h. So pi r squared is the area of the base, the circular base, and then h, of course, is the height of 3 inches. Each of these is also going to be the volume is going to also be the area of the base times the height. Since the base is a triangle, the triangle is going to be 1/2 its base times height. And then we are going to multiply that times the height of the triangular prism. So the height of the triangle and the height of the prism, those h's represent 2 different things. And then, of course, we have the volume of this square prism, or any prism, is length times width times height. So that's what we're going to use. I can find just about everything except for, first of all, I don't know the radius. And in order to solve this, I know the base of the triangle is 2, but I don't know the height of the triangle. So there's a couple things I'm going to need to find. So I'm going to start pulling the pieces out of this in order to work the solution. You, with this problem, once again, are really getting an idea as to how there isn't any one individual piece that's extremely complicated, but putting the jigsaw puzzle together and seeing the big picture is most of the battle. So I need to find the area of this triangle. Each side is 2. And I'm going to label this side of 2 as 1 and 1. Well, I know the base is 2, but I don't know the height. As we've done with many problems, we are going to find the height of that triangle using the Pythagorean theorem. I think we did this for the other problem. I think it was close. I don't have the other solution right here in front of me, but I think, yes, I do have the other solution. It was also a triangle with 1 and 2 for hypotenuse. So we're going to label this h. So we have h squared plus 1 squared equals 2 squared. Sorry about that. All right. So h squared plus 1 squared equals 2 squared. H squared plus 1 equals 4. Subtract 1 from both sides. H squared equals 3. Take the square root of both sides. The height of that little triangle is the square root of 3. All right. Sometimes when you're working through these problems, it's hard to remember why you started the process. But let me remind you, we needed to do this to find the area of this triangle so we could find the volume of that piece. So the area of this triangle is going to be, and it's right here, 1/2 times its base, which is 2, times its height, which is square root of 3. 1/2 times 2 is 1, times the square root of 3 is the square root of 3. So we have the area of that base. The volume is now equal to that area times its height, which I referenced before as this 3. So the volume is equal to the area of the base times the height, which we are actually going to write as 3, the square root of 3. Cool, we got that. Now, the other piece we were missing was the radius of the circle so that we could find the volume of the circle, because we see the volume is pi r squared h. So let me draw that in there. Let me draw the diameter in here. The radius is going to be half that. And that line, this diameter, is made up of this 0.5 plus this, which we just solved, square root of 3, plus this distance from here to here, 2, plus another square root of 3, plus another 0.5. Let's go ahead and write the square root of 3 as 1.73. We'll carry it that way. 1.73, 1.73, and we'll add all that together. 0.5 plus 1.73 plus 2 plus 1.73 plus 0.5 gives us a diameter of 6.46. Therefore, the radius will be 3.23. It's half that. So I have found the volume down here. I have found the volume of the triangular prism. I know the volume of the square prism is going to be 2 times 2 times 3, so this is 12. And now I can find the volume of the cylinder by multiplying pi times r squared, 3.23 squared, times the height, 3. Multiply all that together, 3.14 times 3.23 squared times 3. I get 98.27. 98.27 cubic centimeters for the cylinder. 3, the square root of 3, which I guess I need to estimate as 3 times 1.73, 5.19 cubic centimeters for the triangular prism, and 12 cubic centimeters for the square prism. All right, so we're going to take our volume of the cylinder and we're going to subtract the volume of the triangular prism minus the volume of the square prism. So we have 98.27 minus 5.19 minus 12 gives us 98.28. I'll round that up because I should have rounded that up. Minus 5.19 minus 12. 81.09, or approximately 81.1 cubic centimeters. Here's the correction that needs to be made. I only took out one triangular prism. There's a total of 4. So what I need to take out is 98.27 to start with, minus 4 of these things, 5.19, minus 12. This is not going to work. This should work. 98.27, 98.27 minus 4 times 5.19 minus 12. I get 65.51. The answer given by the author is 63.7. That's just a whole bunch of rounding difference between us. But let me summarize what's going on here. This answer is correct. I think what I did was I rounded not enough somewhere along the line. It's probably carrying 1.73 instead of 1.7 throughout the calculation. But anyway, in summary, long video, cylinder, volume of a cylinder. Take out the volume of 4 triangular prisms and the volume of 1 square prism. In order to figure out the volume of the triangular prism, I had to find the height of its base so we can find the area of the base. Square prism was easy. In order to find the volume of the cylinder, I had to find its radius, which meant using the information from the previous calculations, finding the diameter, and then taking half of it, and then plugging that into the volume formula for a cylinder. Cylinder minus 4 triangular prisms minus 1 square prism. That's the thinking. That's the math. Email me with questions.